So this system of equations has both an exponential portion and it has a linear portion, right? Y equals 2 raised to the x power minus 3 is an exponential equation because my variable is living in the exponent. And of course 2x plus 1, we understand that fully. It's just a linear function with a y-intercept of 1 and a slope pattern of up 2 over 1. So finding the solution to this system can be problematic. First of all, we don't know and deal with logarithms. It's just a tool we'll develop in a later course. But one of the things we can always do is attempt to visualize this system and see if we can figure out where the solution is just based on how it looks. So I'm going to use the TI calculator here and graph both functions. Now, if this was just one equation, if it was 2 to the x minus 3 equals 2x plus 1, I could graph each of these as separate functions and then see where they intersect as well. But here it is two separate functions, right? There's two different equations. So the first one I'm going to look at is just 2 and then raise that up to the x power. And then from that I'm going to subtract 3. The other function I'm going to look at is 2x, 2 times x, and then plus 1. So when I hit graph, fortunately for this system, I believe we can see the points of intersections. And it's possible sometimes if you were to graph this and you saw nothing, the lines could be intersecting somewhere else, but your window is just too small, or maybe it's in the wrong location. This window is raising from negative 10 to positive 10 for x, that's my domain, and for my range I'm running from negative 10 to positive 10. And I can see there's two solution points here and down here. Now the best way to find those with your calculator is just to ask them, where do these two curves meet? And we do that with using the calculate menu, which is right here, it's in blue. So I'm going to hit second calc, and you can see option number 5 is intersect. So I want to know where two curves intersect. Now my calculator is going to ask me, which curves are you talking about? In this case, we're only graphing two curves, right? y1 and y2. But I could have a whole host of different curves on the screen at once. So one of the first curves I want is this one, the exponential curve, which is y to the x power minus 3. So I'm going to select that as my first curve. And then the second curve, y2, is 2x plus 1. So I've selected the two curves, and I want to know where these two curves, the exponential curve and this linear curve, where they meet. And the calculator asks me, well, what do you think the initial guess is? In general, it's kind of helpful to put your cursor just slightly to the left of a point you're trying to find. So I'm trying to find this intersection, so I've gone off to the left, and then I press enter. And my calculator tells me, well, when x is negative 1.625, y will be about negative 2.725. So this is the first solution to this system of equations, right? This is the value of x, comma, this is the value of y. Let's go ahead and find the other value, and you might want to write those down. The other value is, let's go ahead and hit second calc again, another intersection. Same two curves, so I'm going to select this curve and the other curve, and this time I'm going to give it a guess that's just slightly to the left of this intersection point. I'll press enter here. And it's telling me, well, here x is about 3.4 and y is approximately 7.9. So this 3.4 comma 7.9 is another approximate solution to this system of equations. So again, this is how we can find solutions to systems of equations using graphing techniques and our TI-84 plus calculators.